Although wormholes are famous in fiction, few learn how they work. Normally, solving Einstein field equations, you start with a mass like a black hole and find how spacetime is curved. We will do the reverse. Start with an hypothetical spacetime curvature and find out what matter distribution is needed to result in this curvature. This is the metric tensor for the wormhole. Here is the metric written in another way. Note that it's equal to spherical coordinates in the theta and phi components. Why would we choose this metric? For many reasons, but we can see it just visually through embedding diagrams. To do it, first we get metric for cylindrical coordinates. We can rewrite the dz component using the derivative of z with respect to r. Substitute it in the metric, and factor out the dr squared. This component in bracket must be equal to the component of dr in the wormhole metric. We can now do some algebra to isolate the derivative and solve the equation integrating both sides, supposing b of r is a constant function with value r0. Yes, I'll ignore the plus c. Applying this function result in this shape, which should be familiar. Now, I'll proceed to the Einstein field equation to find the stress energy tensor. First, I have to find the Christoffel symbols using this formula. Here they are. I won't go through the process of solving each one because it would be very tedious and time-consuming, just trust me. The same can be done to the Riemann curvature tensor using this formula. But before, we'll switch coordinates to an orthonormal one. This will make the calculation a bit easier. Making another tedious calculation, we find all the non-zero tensors. Then we find the Ricci curvature tensor using this formula, and the Ricci scalar from the tensors that gives this. Finally, we can proceed to the Einstein tensor using the Ricci tensor and scalar, along with the metric that gives the following. Now, using the Einstein field equation, we will find the stress energy tensor. The time component is the energy density rho, the radial component is the negative radial tension tau, and the angular components are pressure. The negative radial tension is also the radial pressure. Combining the Einstein field equation with the functions of the energy and pressure, we get those formula for each one, with 5 unknown functions. We can integrate the energy density function inside a sphere of radius r to find its effective mass. We will now return to embedding diagram. The second derivative of z must be bigger than 0 so that we have the flaring out condition. This is the exoticity function that will be used to find the energy condition of the wormhole. We can combine the exoticity function and the flaring out condition to produce this equation. We know that the energy density must be finite, consequently the derivative of b is finite too. Also, we know that the phi component tends to 0 at the throat. So this function at the throat of the wormhole, that is, at the radius r0, gives this. It means that the radial tension must be bigger than the energy density. This kind of matter with this property is called exotic matter, since we never saw it happen on nature. Also, for sufficiently high speeds, a body would measure negative energy or negative mass. This does not mean we need negative energy for a wormhole, but for a fast body they would measure it. We want our wormhole to be transversable. Suppose we start moving from our space station on the lower universe at proper distance negative L1, and end up at L2 at the upper universe. We have a radial velocity, defined as follow, adjusting the proper time and distance to radius and time using the metric. There is also some restrictions we want. 1. Space is asymptotically flat at the space station. 2. Proper time at the space station must be almost equal to coordinate time. 3. The gravity acceleration at the space station must be less than or equal to Earth's gravity. Using these conditions, you can set up the formula for the time measured by the traveler and the space station, respectively. There is much to learn and show, such as the many solutions for each condition, but for now, I'll recommend you to search by yourself. I read the book, Wormholes, Warp Drives and Energy Conditions, to make this video. That's all. Thanks for watching.